Hi, it's Tessa Folan. I'm back with another video. Today we are going to be finding the distance between a given point and a plane. Right now we're given our plane x minus 2y plus 3z equals 5, and our point, that's from my student ID number, 0, -1, and 3. The first thing that we're going to want to do is to find a point on this plane. We can do this by setting two of the variables equal to 0. I'm going to set z and y equal to 0, and that's going to mean that x minus 0 plus 0 equals 5. And we're going to get a point. I'm going to call it A equal to 5, 0, 0, which is on the plane. Next, just to kind of help visualize going forward, I'm going to draw this out. Alright, so we have our point A, do it in a color, point A, which is 5, 0, 0, and then we have our other point that was here, just say B. That's going to be 0, -1, and 3. And there's going to be a vector that connects them. This vector right now is unknown, but we're going to go vector. And the one other thing that we have from this equation is that the plane gives the normal vector, which is perpendicular, as the coefficients. So that's going to mean that the normal vector equals 1, -2, and 3. Alright, so the next thing that we're going to want to do is we're going to want to find this vector v, and v is going to be from A to B. So we can do 5, 0, 0, minus 0, -1, 3. So we can make vector v equal 5, +1, -3. All right, and with vector v and n, the way that we can find the distance of vector n would be to project v onto n, and our equation for projection is going to be v dot n, it's going to be the absolute value, so it's going to be positive, over the magnitude of n. Alright, so for v dot n, we're going to have 5 times 1, 5, minus 2 minus 9, which equals 6, well, -6, and then absolute value is going to be 6, and then the magnitude of n is going to be equal to 1 plus 4 plus 9, so it's going to be magnitude square root of 14. So our distance from the point to the plane, and the significance of this is that it is the closest distance because we're finding it on that perpendicular, that line perpendicular, and it's going to be 6 over square root of 14. The next thing that we are going to do is we're going to find a line perpendicular to the plane and passing through the point. So this is pretty simple because we have the normal vector, which is going to be our direction vector of the line. So we can say r of t, and we also have our point, equals, so the point we want to use is 0, -1, and 3. And then we're going to plus t times t vector 1, -2, and 3. So that's going to be the line that crosses through. Lastly, we want to find the intersection of this line with the plane. What we're going to want to do for this is to get all our components. So we're going to say x equals t, so 0 plus t times 1, y equals -1 minus 2t. And then we have z equals 3 plus 3t. Now we can go back to our original plane. Here we are. And we're going to plug in each of these parts. So we're going to say t minus 2 times -1 minus 2t plus 3 times 3 plus 3t equals 5. T plus 2 plus 4t plus 9 plus 9t equals 5. All right, we're going to combine our like terms. We're going to have 14t plus 11 equals 5. So then we're going to say t equals -6 divided by 14. We can simplify that. So we're going to say -6 divided by 14. T equals -3 divided by 7. All right. And lastly, to find our point, we're going to take our t and plug it back in. So x is pretty simple. It's just going to be -3 divided by 7. Y is going to be -1 plus 6 over 7. So we're going to have -1 over 7. And lastly, we have 21 over 7 minus 9 over 7. We're going to have 12 over 7. And this point right here is going to be the intersection of the line with the plane. And the significance about this point is that it is the closest distance from the plane, from the point on the plane. It's that closest distance. Thanks for watching. I hope you enjoyed and learned something new today.